Okay, Lab 1, Physics 2212. For the introduction, the purpose of this lab was to create a charge tape and figure out the magnitude of the charge on that tape. We made 2 charge tapes, did an experiment with them to figure out that charge, and a number of other things such as electrons and atoms. You can see that result overview right here. Charge, force of gravity, force of electric field, electrons, atoms, and then the ratio of those respectively. Continuing on in our introduction, we have the system, tapes, surroundings, the earth, and here we have models on the experiment and how we actually created the tape. So you layer a base tape on a table, you put a U-tape or an upper tape on top of that with a little handle, and then you just quickly rip it off, and that's how you get your charged tape. So you basically do that for 2 of them, you bridge one of them, and then you bring the other one closer and closer until you see the first one start to float, and you measure the separation distance between that, and we use that in our experiment. With these concepts and assumptions, so the concepts, aka the equations, we have gravity, electric field, force electric field, the number of atoms, which is just this, this fraction right here. To get the surface area of the atom, you use that the length of one atom is an angstrom, which is 10 to the negative 10, square that, 10 to the negative 20. Total charge equation, and for the principles, we have Coulomb's law and Newton's second law, and the assumptions we made was that the long tapes are treated as a singular central point. Both the charge tapes had we assumed that both the charge tapes had an equal magnitude of charge, as they were of roughly equal length and prepared in the same fashion. We did not account for air resistance or any other forces in the y direction, and using these assumptions greatly simplified our calculations, while still giving us the bigger picture and the interactions. So for the interactions, the 2 charge tapes repelled each other, and they were also attracted to neutrally charged books, or neutrally charged objects. And if you charge up a plastic pen, rubbing it in your hair, you give it a negative charge, the charge tape ended up repelling away from it, so therefore we concluded that the charge tape was actually negatively charged. And here for our experiment calculations, using those concepts and equations and the forces, because the tape was floating, we assumed that the y direction force is equal to 0, so force of gravity is equal to electric force, and manipulating that, we can get that the charge of the tape is equal to the square root of ma times separation distance over Coulomb's constant. And then using that, we can find the number of excess electrons. Then we find the number of atoms on the tape, and we get the ratio. And you can see that in our glowscript code right here. We got the constants, the tapes, aka the spheres, r vector. We have the calculating the charge of the tape right here, the square root equation that I was talking about earlier. And then using that to get the forces of gravity and forces of the electric field, get the number of electrons, number of atoms, ratio, and then drawing the arrows, and you can see the results right here. And now we move on to our sources of error. So one possible source of error stems from the treatment of the charged tape as a point particle right in the center. And another source of error is that we didn't account for any other forces such as friction, air resistance, or any other gravitational electric forces that were acting on the tapes. And we also treated the charge of the tapes as they were of equal magnitude when they were most likely not equal. And also the separation distance and mass could have been calculated a little differently. I could have used a wider tape than convention, resulting in a different mass, and the separation distance was measured with a ruler. I could have been a bit more precise with that, with a different instrument. For the what ifs and whys, so what if the charges of electrons and protons were flipped? I believe that the tapes would still interact the same with each other and with other objects, such as the neutral object and the now positively charged plastic pen. I believe they will still repel and attract in as they did before. Why is it important to handle the tapes as little as possible? When they come into contact with anything, or you handle them too much, the charge dissipates and the excess electrons find a new home, and this can mess with our data, such as the separation distance, and then it'll just domino and change everything up. For our conclusion, we have that forces due to electric fields have a considerable effect on objects around us. Making assumptions makes calculations much easier without sacrificing accuracy, while still giving us an idea of the bigger picture, and some of these assumptions are as listed. And also, we use glowscript to not only model such interactions, but also to calculate the charge and other values as shown previously in the slides. And that'll be all. Thank you.